Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 5, longest palindromic substring. For this problem, we're given a string S, and we want to return the longest palindromic substring in S. So before we even begin to develop an algorithm, let's first understand what a palindrome is. A palindrome is a string in which the word is read forwards and backwards in the same manner. For example, we have the palindrome A, B, A. You can see that if we read it forwards, it's ABA, but if we read it backwards, it's also ABA. Another possible palindrome is ABBA. And in the same way, if we read it this way, it's ABBA, and if we read it the other way, it's ABBA. So by definition, it's a palindrome. It's also important to note that there are two types of palindromes. There are palindromes of odd length, and there are palindromes with even length. Okay, now let's take a look at some examples. So for this example, we have the string BABAD. We want to find the longest palindromic substring. So one way to approach this problem might be to find out all the substrings in the string, check if the substring is a palindrome, and then return the longest one. So how would this algorithm look like? Well, we begin at B, we check if it's a palindrome, which it is, so we store B as the longest palindrome thus far. Then we check BA. Well, this isn't a palindrome, so we just continue looking. Then we check BAB. Well, this is a palindrome, so we update the longest palindrome to be of length 3, namely BAB. And this is what we'll actually be returning at the end, because in this string, this is the longest palindromic substring. And if you notice, there can actually be multiple palindromic substrings of the same length. So for this example, we have BAB, but we can also have ABA. These are both palindromic substrings, so we can return either one. Well, what would be the time complexity for such an algorithm? Well, we know we can return all these substrings in big O of n squared time, and verifying a palindrome has a big O complexity of O of n. So if we combine these two steps, we'll actually get big O of n cubed. Well, this is not the best approach to this algorithm. So how can we go about developing a faster algorithm? Well, for the brute force solution, we're always starting at the start of the string and going forwards. So what if we just start somewhere in the string and expand outwards to the left and to the right? Well, for this example, there's actually nothing to the left, so the longest palindrome from this index is going to be just B. However, if we start from A, we can expand outwards, and we see that the letters on the left and the right are the same. So this becomes a palindrome by definition. But as I mentioned previously, we have to keep in mind of the difference between odd length palindromes and even length palindromes. Well, the difference is if we start at some index and expand outwards, we'll see that this is not going to be a palindrome because C is not equal to B. But really, this is a palindrome since we need to start at the 2 center characters instead of just 1, and then expand outwards from this. And in this case, the longest palindromic substring would be BB. So does this actually improve the time complexity? Well, it actually does, and we have a time complexity in the worst case of O of n squared. This is because we have to loop over the entire string and expand outwards from each character. So traversing the list will take big O of n, and expanding outwards will also take big O of n. And combining these, we'll get big O of n squared for the time complexity. And obviously the space complexity will be big O of 1 since we're not using any additional data structures. We're just expanding the string using pointers and references to the indices. With that being said, we can go ahead and write the code for the solution. Okay, we're on LeetCode and we can start writing the code. Since we want to actually just return the longest palindromic substring, we'll keep track of the start index and the end index for the longest palindromic substring and just return a copy of that using Python slicing. So we can go ahead and initialize the longest start and the end. So we can say longest start and longest end. We'll say this is 0 and 1. And these are the indices of the string. Next, we can go ahead and loop over the entire string. So we can say for index in range over the text. And we want to make sure that we're keeping track of the even and odd cases. So we could just loop over tuples and assign them that way. For the odd case, we know that the starting left and the starting right are just going to be the index itself. But for the even case, the starting right will be one more than the starting left, since it's 1 over. So we can just write for left and right in index and index. So this is the odd case that we're just unpacking. And we also want to loop over index and index plus 1. So this is the even case. So we also want to ensure that the pointers are always in bounds. So we can do a check to ensure that and exit once the pointers are out of bounds. So we can say while the left pointer is less than or equal to 0 and the right pointer is less than the length of text. And we also want to make sure that the left and the right characters are the same, hence being a palindrome. So we'll say text of left is equal to text of right. And while this loop is continuing, we know that we're in bounds and that it's still a valid palindrome. We want to expand the substring, so we can just decrement the left pointer and increment the right pointer. Once we break out of the loop, we know that we're either out of bounds or that it's not a valid palindrome. So we have to check if we reached a new longest palindrome. So if right minus the left minus 1, because the pointers will have been 1 more than we need, we want to check if it's greater than the longest end minus the longest start. And if it is, we're going to just update the longest starts and the longest ends to be left plus 1 and the right. Finally, we can just return the new palindromic substring, and since we have the indices, we'll just say text and we want to start from longest starts and go to longest end. So that should be the code, and we can go ahead and submit it. As you can see, it's accepted and it's pretty fast. So hopefully this video helped you and you learned something, and I'll see you soon.